Alright, so this is going to be a quick video on how to figure friction loss and basically pump discharge pressure when we're trying to figure out things for testing purposes. So as you can see here, the top is PDP, pump discharge pressure, equals friction loss plus nozzle pressure plus or minus your elevation plus your any appliance. Okay, so that's ultimately what you're wanting to figure out when you're pumping an apparatus. But the biggest concern that most people have is just how to figure friction loss. So the friction loss formula, the standard that you're going to use in any of the tests, is going to be your friction loss, which is C times Q squared L. Okay, so C stands for coefficient, Q stands for quantity, and that's how much water is going through in GPMs over 100, and then length, of course, is your L, and that's per 100 feet, and that's over 100 as well. So you can see here, I already wrote out the coefficients, the standard coefficients that you're going to use in the fire service. Your 1 3/4 is 15.5, your 2 inch is 8, your 2.5 inch is 2, and your 3 inch is 0.8. Okay, so kind of get down to how to go about doing friction loss and calculation. So let's just figure we're going to be pumping just our regular 1 3/4 pre-connect. So it's 200 feet, right? So if what we want to do is we want to plug in our coefficients or everything that we know. Okay, and so what we know is your coefficient for 1 3/4 is 15.5. Okay, we'll skip right now the Q and we'll go to length. Okay, we know the length is 200 feet, right? So it's 200. Okay, now quantity, whenever we're doing so quantity, what we were talking about before is we're going to just assume that where desired to flow is 150 GPM. Okay, so what we're doing is it's 150. Okay, but we need to put it in. We got to divide that by 100 as well. So if we divide anything by 100, and this is what we're going to do here, instead of dividing it by 100 and actually going out doing it, your decimal point's at the end. Okay, when you divide something by 100, you go to the left 2 decimal spots. 1, 2. So it's 1.5, 1, 2, 2.0. Okay, so rewriting the equation is 15.5 times 1.5. Make sure we put the square, bring it down, times 2. Okay, so this is what we want to figure out. All right, so 1.5 squared is 2.25 times 2 times 15.5. Okay, more than likely you may use a calculator, or you might have to do it all out. But you know, just do 15.5 times 2.25. And then double that to get what you want. So your answer then is 69.75. Now, that is just your friction loss. And this is one of the things that I think confuses people the most. This is just your friction loss. So remember, when we go back to our pump discharge formula, this is all we're doing is figuring out that there. Okay, so what we want to do is when we are plugging into our formula down the road to actually pump the truck, is 69.75 is just the friction loss in that hose. It does not account for anything else. So then we want to add in the nozzle pressure. Okay, we're using our fog nozzle, so we add in 100, okay, to the fog nozzle. And that is why when we are told pump discharge pressure of just a regular 1 3/4, you're going to be pumping 169 69.75 psi. All right, so that is what you're going to come up with for testing purposes for an 1 3/4. So 1 3/4 pre-connect, okay, which we all use 200 feet. All right, so for a regular pre-connect, we're pulling off our truck, you're going to be pumping at 169.75. Now, we will not have any appliance, so we're not going to add anything to that. But understand that if you're going up or down flights of stairs or down elevations, maybe you're going down an embankment, car fire or something like that, you're going down. Understand you need to plus or minus psi per 10 feet. All right. So we'll just assume it's on a flat surface for now. So that is how you do your coefficient for 1 3/4. All right, so now we finished the 1 3/4. Now we're going to talk about, all right, what happens if we fly the Y, right? So we're going to put up here 169.75, right? So that is what our friction loss is for our 200 feet of 1 3/4 pre-connect. Now, what happens if we have to go a long, long distance, right? And we have to fly the Y. So now let's think about what we want to do, okay? So bring back our equation here. We need to now figure out the friction loss from the truck to that Y, all right? Now, we're still only using one line. Now, because we're using one line, there's a rule of thumb that if it is below, and depending on which book you read, it's 325 or 350. We're just going to go with 350 GPM. If we're using 350 GPM, the appliance is negligible. You don't have to calculate any friction loss for the appliance. Okay, so we're still only flowing one line of 150 GPM, so understand that we don't have to add for the appliance. Again, we're not going to add for elevation for simplicity. But what we want to do now is we want to look at the coefficient so of our 3-inch, right? So we've already, if we have our truck here, okay, and we have the Y there, and then from this point we have our pre-connect, okay. So far we have figured out this is 169.75. This part right here. It's really 69.75, but we're just assuming we're already adding into the nozzle pressure. Now we are needing to figure out this section right here. So we're going to say we had to, it's a long, long, long leg. For some reason, I don't know why we had to go up a huge, driveway. So we're going to say that's a 300-foot leg. Okay, so coming back here, all we do is plug in, we're looking for this section here. So now we're looking at a coefficient of 3 inches, right? We're going to use a 300 feet of 3-inch hose. Okay, so our coefficient is 0.8. Okay, our quantity is still the same. We're still flowing only 150 GPM. So we do 1.5, because remember, it's really 150, and then we move the decimal point over, or we divide it by 100. And then we are doing, this time, we're doing 300 feet. So it's 300, move the decimal over twice, or divide it by 100. Okay, so the new equation that we have here is 0.8 times 1.5 squared times 3. So now take your calculator out. Okay, again, your 1.5 is going to be 2.25 times 3 times 0.8. Now, real life scenario, if this is real world, that is so close to 1, you're going to basically eliminate it. Okay, anything you times by 1 is itself. So in real world, if I was actually calculating this on the fire ground, I'm going to just eliminate that. Okay. However, in testing purposes, you cannot do that. So what I will do is 0.8 times 2.25 times 3 is 54. So what you come out with is 54. Okay. Anyway, so what I realized I did is I didn't put the decimal when I put it into the calculator. So instead of 54, it's actually 5.4, which makes a whole lot more sense. Okay, so you are adding now 5.4 pounds to that PDP. So now, instead of having 169.75, you now have 175.15 psi. Okay, so you're going to pump your truck at 175.15. Obviously, you can't do that, so you get as close as you can. All right, so that is how you calculate the whole entire stretch of hose according to the testing. So this is how you actually do it on pen and paper when you're going for promotional assessments or doing any kind of exam. Understand in real life, you're going to just say that's negligible. You're going to say two. Basically, what I would have done is 2 times 3 is 6. Okay, 6 is what I would have used for my my extra psi. So I would have, again, I probably wouldn't have been using 169.75, but if I would have done that, I still would have come up to 175. I would have just done 169 plus 6, and I still come up with 175. So you can just see how really a 2/10 of a point really is not going to make that much of a difference in your overall calculations. So that is why when we do what's called the condensed Q, we eliminate the 0.8 and we just make that as a 1, and just know that that's a negligible difference that you can just eliminate. All right, so the next thing we're going to start is, you know, it's pretty easy when you have a fixed stream like a fog nozzle, and we know that it's 150 gallons per minute. Well, what happens if we have a smooth bore? And this is really where, for paper purposes and actually a test purpose, this actually becomes much more cumbersome of an equation, because before you can get to the Q, you got to figure out what you can actually flow. So the next formula you're going to need to know is the GPM formula. The GPM formula is 29.7 times the square root of the nozzle pressure times diameter squared. Okay, so as we look at the different chart or the different things that we actually flow, if we look at the nozzle pressures, we only really have you know, 2, right? So you have a hand line, which the nozzle pressure is, remember, 50 psi. Or if we have a master stream, okay, it is 80 psi. We also have high-rise nozzles, but for now, we'll just talk about these two because different departments have different nozzles. Sometimes you have 75, but for now, we'll just talk about 50 and 80. In, again, a real-world scenario and not using a calculator, you know, the closest square to 50 is 7, and that's 49. So 49, you know, if you square root that, it's 7. And then the closest one for here is 9, and that's 81, right? So 7 and 9 is what you can plug in for nozzle pressure. But so knowing the different tips that we use, we'll just talk about what we're going to calculate for a hand line. So you have the different tips, and I'll write down the different tips. So if we're talking about the different tips that we might have on your hand line, every department's different, but we'll just say that you can have an inch and an 1/8, and an 1 1/4. Okay, so those are the 3 tips that you more likely see on hand line. For east right now, we'll just say you have the inch tip on. So the way you calculate this is, again, transpose everything times the square root of nozzle pressure. So you know that it's the square root of 50, okay, times diameter, we'll just do 1 squared, okay. Now, anytime 1 is, anytime you, again, you multiply anything by 1, it really just it just is negligible, so it doesn't do anything, it's just times it by itself. So really here, what you want to do is, it is 29.7 times the square root of 50. And I'm going to use the calculator. Like I said, square root of 50 is going to be 7 point something. But let me tell you exactly what it is. Equals 50 square 50 square 50 equals 7.07. Okay, so 7.07 times 29.7 equals 210 GPM. 210 gallons. Okay, so when you typically do any kind of, well, you may have heard some kind of rule of thumb chart. You're going to have 200, 250, 325, right? So you can see where these numbers kind of come from. 210, instead of remembering it's 210, it's 200, 250, 325. Again, this rule of thumb chart is something that is easier to remember, but it's all based on calculations. In an actual testing scenario, you need to know what this is. So now that you have 210 GPM as your GPM, then you change everything else. Okay, so your coefficient. So we can say what is now you're flowing your 200-foot pre-connect, but now you're flowing a smoothbore nozzle. So you get back up here and you say 15.5 times 2.1 squared times still your 200 feet, right? So times 2, all right? And you're going to see how this is going to change. So 2.1 squared is 4.41 times 15.5 times 4.41 times, and again 2 equals. So you come out with 136.71. Again, this is only what the friction loss is. Okay, now instead of adding in, all right, so back to this equation. So if you, for some reason, are using an 1 3/4 hose for this scenario, you are going to come up with this. Then you add another 50 to this is 186. Because I'm kind of rushing through this, I didn't realize that when I was doing it that we are not going to be having a well, I guess we would, but so anyway, so if we add your 50 pounds to your nozzle pressure, you're going to come up with 186.71 is going to be your pump discharge pressure of your 1 3/4 nozzle. Okay. Now again, I want to point out that this is all, true calculations based on the math. Understand that when you are actually pumping, you need to know a whole lot more. You need to know the capabilities of your fire hose, Oftentimes the new fire hose, the coefficients are much less than 15.5. So for instance, our hand lines now on our trucks, we actually pump it at 120. Okay, our 1 3/4 with and I can't remember which tip is on it right now, but we're pumping at 120. 186 is going to be a very high pressure for a hand line for an 1 3/4. But understand that this is what the math does show you. Outside of that, I think this will hopefully give you an understanding of how to calculate friction loss. It's very important. Anytime you do math, one of the things that I stress, anytime you do math, that you be very careful and neat. The more you line things up and the more you just bring things down, the less mistakes you'll make. Okay, so here you just bring down the 29. Make sure you bring down the squares, because if you don't, you're going to eventually be messed up down the road. So I hope that you gained a little bit better appreciation of this, and of course I can help out in any way. Now that you have this, I can help out over the phone.